Welcome to Get Your FRQ On. This question is from 2009, Form B. It's question 1 and it is calculator active. In the question stem, we've got a tree trunk with circular cross sections. We have got a function for the radius of the tree trunk, which is r of t, and that grows at a rate given by the function dr dt equals 1 over 16 times 3 plus the sine of t squared centimeters per year. This model is good for values of t between 0 and 3, where t is measured in years. We're given at time t equals 0, the radius is 6 centimeters, and that the area of the cross section at time t is denoted by the function a of t. In part A of this question, we are asked to write an integral for the radius r of t between 0 and 3, and then to find r of 3 using our integral. Now, since r of t grows at a rate of dr dt, which is given to us in the question stem, the radius r of t would be given by an integral of dr dt. And since r of 0 is 6, the desired integral for r of t would be r of t equals 6 plus the integral from 0 to t of 1/16, 3 plus sine of x squared dx. Note the use of the dummy variable here, since the value of t is used as a variable in one of the bounds. We cannot use it in the function itself. And then using this to find the value of r of 3. R of 3 would be 6 plus the integral from 0 to 3 of that expression. However, this is a calculator active question, so we can use our calculator to evaluate that integral. Using a calculator, we find that r of 3 is 6 plus the integral from 0 to 3 of 1/16 times 3 plus sine of x squared dx, which turns out to be 6.611 centimeters. In part B of this question, we are asked to determine the rate at which the cross-sectional area A of t is increasing at t equals 3 years and to provide the units. Since the cross-sectional area at time t would be given by a of t equals pi times r of t squared, that's just the formula for the area of a circle, the rate at which the cross-sectional area is increasing is going to be given by the following expression. A prime of t equals dA dt, which is going to be the derivative of pi times r of t squared, which will be 2 pi times r of t times r prime of t. To find the rate at which the cross-sectional area is increasing at t equals 3, we can just evaluate a prime of t, and since it's a calculator active question, we will use our calculator to do that. A prime of 3 is 2 pi times r of 3 times r prime of 3, which is 2 pi times 6.611 times r prime of 3, which is going to come out to 8.858 square centimeters per year. In part C of this question, we are asked to evaluate the integral from 0 to 3 of a prime of t dt and interpret its meaning, including the units. So because this is a definite integral, by definition, or the fundamental theorem of calculus, the integral from 0 to 3 of a prime of t dt would just be a of 3 minus a of 0. And since this is a calculator active question, we can use our calculator to find that difference. The integral from 0 to 3 of a prime of t dt, which is going to be a of 3 minus a of 0, turns out to be 24.201. So what this means is that from time t equals 0 years to time t equals 3 years, the cross-sectional area of the tree increased by 24.201 square centimeters. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.